So we're here at the Museum of Clean where we've done our mechatronics project, where we were tasked with developing a system for doing a simple task as complicated as we could. So what we have here is a 3D printer style frame that cleans a window using a squeegee. We have a pump down there that uses water and pumps it to these squirt guns here. They'll spray the window and kids can interact with that. And once they're ready, there's a button over there that will allow the arm to start its sequence and clean the window. We'll show you that now.
Yep. Okay, so like Kate was saying, we have these squirt guns, and so we basically set it up for 3 different guns so we can have like 3 kids come and play with it. And just so you can see, we have the movement restricted, so you can only move the squirt guns a certain amount. That way they can't just squirt each other and get everything wet, and you can only move it up a certain amount. So now I'll just show you them working. James, come on and grab that one. Yep. Just so you can see that all 3 can be sprayed without losing any significant pressure. And then, so now that the window's all wet, all you have to do is come over here, click this button, and the robot will start moving. And then just so you can see too, once this is moving, the pump shuts off, so you can't spray it, because kids would love to spray a moving target, so we want to prevent that from happening. So.
More of a streak-free shine than Windex.
Oh yeah.
So this is controlled using an Arduino, and then we're using stepper motor drivers, which are in this box right here. And the Arduino is mounted right here, and then we have a breadboard that has all the controls on there. There's a limit switch on this, so that if ever the program crashes, it'll go back and home itself. And then we also have that switch wired up to it. So the 2 drivers of these red chips here, here's our Arduino. And then we also have a power supply right here. This is what powers the motors. Because the Arduino doesn't supply enough power to actually do that.
So coming back out to the front, I'll explain to you a little bit more about the project itself. So here, it's made out of 80-20 aluminum extrusions that allow for linear motion and many different attachments to be attached easily, and it also makes the system modular in its design. You can see right there it just homed itself and finished its run, and it's ready to spray again. But while it's spraying, you'll see that water has collected all over the place, and it's sprayed all along the walls, and it is collecting to a central point where it drains into the bucket underneath where the pump is located. The water collection system is fairly simple in its design, mainly for the task of allowing the museum to customize that however they want to express the museum better in their own sense of style, without spending a lot of money in a temporary situation. So walking back up to get a closer look too, we'll show you a little bit more of the electronics up on the front end. So we've got 3 motors that are running this, stepper motors, 2 smaller ones doing the x-axis and a large one doing the y-axis. To operate the squeegee itself, we have a 180-degree servo motor. All of these are water resistant to allow for the design to last for a long time, as well as the aluminum obviously being weather resistant as well. Under here is where the limit switch is located, which, as you can see, the arm touches every time that it comes over. As you can see, this is belt driven and uses a bearing system to propel itself in that linear motion. So once again, this is our project for mechatronics in the Mechanical Engineering Department for the Museum of Clean in Pocatello, Idaho.